This question here is going to test our knowledge of the discriminant. They're telling us that the equation that they've written here with k's in it, k's a constant, has no real roots. What does that mean? Well, I've got three quadratics here. Here's number 1, number 2, and number 3. Number 1, you can see, has no roots, no real roots. There's no value of x that you can pop into the equation which gives an answer where the curve actually falls below 0. Quadratic number 2 just touches the axis at one point. It has one root, and there's the root there. The third curve touches and crosses the axis at 2 points and has two solutions to the quadratic formula. In other words, when we use the plus and minus here, we'll get two real answers. Now, the quadratic formula is basically the determinant as to whether there'll be 1, 2, or no solutions. And that comes from the value of the square root. If the value of this square root is positive, in other words, if b squared minus 4ac is above 0, then the square root is possible and we get two answers from it, a positive answer and a negative answer. If b squared minus 4ac is 0, then plus or minus makes no difference. We will get the same answer, and that's this occasion where the curve just touches the axis. Now, the third case, the case of this curve here, b squared minus 4ac is negative, below 0, and we can't take the square root of a negative number. It doesn't exist. Well, no real solutions exist. That's why they talk about real roots all the time. If I start introducing the square root of minus 1 or I, yes, I can get solutions, but they are not real solutions. So with that knowledge, let's go ahead with the question. If this equation has no real roots, it means that b squared minus 4ac is indeed negative. And we can express that this way. So I can say that b squared minus 4ac is less than 0. So let's pop in the values. We've got that b is equal to 4k, a is equal to k, and c is equal to 3. They are all positive. So let's substitute into our discriminant formula. So first of all, I can take a factor of 4 out of this equation because 4 will go into 16 and 4 will go into 12. So I get, therefore, 4k squared minus 3k is less than 0. Now, if I factorise and take a common k out, I get that k. Now, I know a lot of students get confused at this point, but you need to examine what you are asking here. You're saying, when is this curve less than 0? Let me explain. I've got no idea whether this curve is anywhere near correctly positioned on the axis, but it will do. And I know it's a U-shaped curve because the 4 in front of the k squared is positive, so it is a U-shaped quadratic. We want to know the region, and in this case it is this region here, when the curve is less than 0. So we've got a 0 crossing point here and another 0 crossing point here. Effectively, they are our goalposts between which our curve falls down below sea level, below the level of the x-axis. And because we can't determine those points with an inequality here, we've got to add the line at the critical points. Our expression equals 0. So what that means is that the points at which the curve does dive below the axis are at the goalpost points, which is defined by this relationship here. Now I can say that, therefore, the solutions to that equation are that k must equal 0 or 4k minus 3 equals 0, and therefore k is equal to 3 over 4. So my guess of the goalposts was wrong in this diagram, and let me correct as best I can. because in fact the curve crosses the axis much more like that. So the region the curve falls below the x-axis, or should I say k for this occasion, because these are values of k that we're working out, the curve falls below the k-axis between 0 and 3/4. So I can say that that region is defined by the values of k being between 3/4 and 0. But we actually have another solution here where k is 0. So this modifies the inequality that will include 0, but it does not include 3/4. You see, at 3/4 the curve is 0. It's not less than 0. So that, you'll find, is the proof they required.